Hi, welcome to the ZP Developer Zone. So we do this webinar answering technical questions regarding sensors, biosensors every Thursday at 8 a.m. London time. And really we'll just jump straight into it, I think, because there's lots to cover. So we do have our ZP Academy. So there are a couple of free courses on the ZP Academy. So if you're unsure about biosensors and electrochemistry in general, then take a look at the ZP Academy. There's obviously a whole spate of webinars, at least once a week in the ZP Developer Zone, and then we do other webinars with other organizations. We do have our collaborations, our jobs, and our ZP Developer Zone website. Something that has changed more significantly of recent is really the workshops. So unfortunately, during COVID, we didn't have any live workshops, but this is something that we've really started in earnest. Every time you see a link jump up, I just want to kind of say that every time you see a link, you will be able to find that underneath the video. But we do have a whole series of workshops running in 2022. We're really trying to sort out a workshop in India at the moment. There are slight visa issues between the UK and India at the moment. So we're trying to organize workshops in India. We do have workshops in the US, we do have workshops in France, we do have workshops in Norway, and we do have workshops in the UK. So I would say we've got a lot of the globe covered in terms of workshops, and these are probably one of the best places to actually get the kind of training and the more in-depth answers to technical questions. Now, regarding questions this week, we've got a question here: how to calibrate a glucose sensor. So I will cover and answer that in this webinar. Making a biosensor for inflammatory markers, we'll cover that. Question number 3 is about sensing for pesticides, antibiotics, and hormones. Question number 4 was a bit of a question that we've had a few times on this in this webinar, is difference between generation 1 and generation 2 glucose sensors, but we haven't done it in a while, so I don't mind returning to it now. Question number 5 is, can we print carbon and silver chloride electrodes on flexible substrates? Of course, the answer is yes, and we'll cover that. And then number 6 is how to use a glucose sensor. So it's kind of interesting in some ways because, question 1's about glucose sensing, question 4 is about glucose sensing, and question 6 is about glucose sensing. So to get a really sort of comprehensive or more rounded answer on glucose sensing, watch the entire video, I would suggest. Just to say that if you're interested in biosensors, we do have quite a glossary of terms on biosensing. Again, if you see a URL or a link, that will be underneath the video as well. So question number 1, is there any video or guides available for calibration of ZP glucose sensors? So the quick answer is, I'm going to make a side note here that the Inquirer has glucose sensors from Zimmer and Peacock, and they have some strange results. I do want to note that, but I also want them to sort of put their question more into a presentation format so that I can follow the question more easily. So I want to acknowledge that as a question come in, I sort of understand it from an email and a couple of attachments, but I think it needs to be laid out in a bit more of a presentation format. The way that I'm doing here, so it's there's a narrative to the question, so I'm a little confused. I want to jump now to the second part of that question, which is actually about calibration. Now, one way of calibrating a glucose sensor is, and this is something that we do and we talk about in the workshops, and we do it in the workshops, is, we'll take a beaker, we'll have a magnetic stirrer bar in there, we'll put the glucose sensor into that solution, and we'll do an experiment where we've got the electronics running and we have signal, and the first thing we'll do is we'll run something like 0 millimole of glucose on the sensor. We have this break-in time, and when it's plateaued, that's when we then add an aliquot of quite concentrated glucose solution. So this is the way we sort of often do it in-house. Start off 0 millimolar, the sensor's in the beaker. Somebody doesn't, when you do this, there are a couple of videos that I will be showing later on related to question number 6. You'll see videos of Andre actually doing this. But 0 millimolar of glucose, you add in the aliquot and the signal jumps up. So we add in a concentrated drop of solution so that we get an overall 5 millimolar solution in that beaker, and we add in some more, another drop of very concentrated glucose solution, let it stir in, get 10 millimolar, add in another drop, get 15, add in another drop and get 20. So when we're doing, so I would describe what we do as industrial scale testing of sensors. This is not a few lab experiments. We're doing this on quite a scale. This is one of our sort of standard ways of, let's say, calibrating a batch or calibrating a glucose sensor. Obviously, I think everyone most people who watch this channel know this, but, I'll just spell it out. The way we then do it is, we take the signal at 0 millimolar, we plot that signal. We take the signal at 5 millimolar, we plot that signal. 10, we plot that signal. 15, we plot that signal. 20 millimolar. And from that, then it allows us to calibrate the offset and sensitivity. This is a straight line that we often use, and the signal is equal to the gradient times the concentration plus the offset. Is the general kind of equation that we follow. It is worth knowing that if you come to one of our workshops, this is one of the experiments we do. And what was really nice about one of the workshops that recently did is actually people made the glucose sensor. By the time everyone had made a glucose sensor, they'd all cured, and then we were able to actually do this experiment. So FYI, if you really want to kind of understand the intricacies of doing this kind of experiment, then try one of our workshops. Now, Julie is the crown jewel of everything that we do at Zimmer and Peacock. So actually Julie, you can sign up for free on Julie, by the way. It can automate the calibration of glucose sensors. So I just described, how we do it. We add a drop of very strong glucose solution into a solution, let it stir in, and we keep adding drops and the concentration keeps going up. I must admit the data itself is not that good here. This is one of our sort of tries that we were doing or something. But Julie allows us to upload the data and actually automate the analysis and the extraction of the calibration curve. In fact, I can see here that it's combined these three data sets and has given us a signal is equal to the offset, which is 4.26 in this case, plus the gradient, which is 0.215 times x, which was the concentration. So Julie is actually able to automate the analysis of this. And so if you're really serious about, I just want to say hi to Aftab, morning Aftab. So if you're very serious about glucose sensing and glucose sensor development, you do have to get onto Julie, because it's going to automate your data collection. Otherwise, you're going to have, a lot of data, and you'll spend more time sort of sorting out spreadsheets than you will actually sort of adding value. So the answer to the question is, I hope that gives you an indication of how we, first of all, test the glucose sensor. There will be a couple of videos in question 6 which will show Andre actually doing this kind of work. Also, if you're really getting into this quite seriously, you have to look at Julie, because it will help you automate your data analysis. All right, I'll go a bit quicker. Now, question number 2. This was an interesting question. They wanted to develop a wearable inflammatory marker system. So it's really like a CGM, a continuous glucose monitor. So there's many parallels between what they're trying to do and what modern glucose developers are also doing. So they want to detect inflammatory factors. That's fine. They want wireless transmission, real-time monitoring, and they also want to do on-demand intelligent drug delivery. So this, I'm going to cover the first 3 questions. I could actually also cover number 4, but I want to say this. What you're trying to do is really similar to something called the artificial pancreas. The artificial pancreas is an idea in diabetes management, and it's actually a product as well, where you have a continuous glucose monitor that's worn, and the continuous glucose monitor that is worn is then controlling a insulin pump, and they call that the artificial pancreas. So I just want to say that this is a, let's say, new disease application, but the principles are already quite known in the medical devices industry. So I can basically rely on my CGM knowledge to be able to answer this question. So they want to measure inflammatory markers. They've got IL-6 here, INF, gamma, TNF alpha, for example. All right, this is fine. You know, these sensors can be made. Now at ZP, we do have a wearables platform already. It's a little tricky for the inquirer on this one because I know they're in China and they sometimes have problems with YouTube in China. I do understand that restriction. But at ZP, we do have a platform for making wearable technologies. And we do have a lot of microneedle technology. I haven't labeled this particularly well, but you know, microneedles are a more sort of modern way of getting into the interstitial fluid. So you have the kind of stratum cornea up here, you have the interstitial fluid region, and microneedles are able to sort of penetrate into there. And so if you functionalize the electrode appropriately, then you can do things like inflammatory markers. I will I'll go forward a little bit and say, you know, we do have this kind of microneedle technology, and we've been working on this kind of technology for a very long time. Tens of thousands of person hours has gone into this kind of work at ZP. It's not easy to do, and you know, I'm biased. I understand that, but it is a good idea to work with ZP if you're going to do this kind of technology, because you could be 8 years doing this before you're really making progress. We do have a set of technologies for people who want to do wearables. You know, so we have a whole range of biosensors. We do have electronics, which already have Bluetooth in them, and they can connect to apps, and apps can connect to again Julie. So you see Julie appears a lot. I know I've said it already. Julie, there is a free sign up for Julie, so don't be super concerned about the cost. And that means we can get the data to the cloud. So just some details about that device. It does have a very small electronic set in it. By the way, this electronic set will appear later on as well. We do sell these electronics as well, but at the heart, you know, what's going on here is we have the sensors themselves, a PCB. This is that PCB, and we have a Bluetooth module as well. So we have that sort of Bluetooth connectivity, and this is all technology that many of you who watch us, you know, are engineers, and so this is kind of straightforward. The thing that's probably really valuable is actually this PCB at the heart of what we do, and I do have links to that underneath this video, and I'll emphasize it a little bit. Just to say where our technology is today. The ZP technology in CGM is really quite advanced. I mean, I know this is a very particular application, but this is, again, there's a link here. This is really for implantation. I'm not suggesting for human because it's fairly small, but it's too intrusive for human. But here we're actually implanting it into fish. So we do have continuous glucose monitoring and continuous cortisol monitoring, for example, in fish. And we do have a whole technology stack around that, and that's why I've put that link there. In fact, that's quite a nice shot. You can see that PCB that I was referring to earlier on. You can see the sensor itself. This sensing tip is the actual sensor itself. I just want to warn, this is in particular to this inquirer. This inquirer is asking, can you make a wearable biosensor for inflammatory markers? It's got to have Bluetooth, and it's got to be able to control a pump. The easiest parts are actually all the engineering and even the sensing part. The hard part is you've got to, at least in the USA, be able to raise something like $196 million to do this kind of work. This is what BioLink have raised to do their wearable glucose sensors, and I would suggest that inflammatory markers are probably tougher than glucose. Question number 3, I'll go quite quickly. Do you have any sensors for pesticide analysis? I think this is really quite an interesting question. We did used to get a lot of these kind of questions from all around the world, but they also stretch on to say about hormones and antibiotics, so I will jump into it now. And are they for laboratory use, or can they be used in the environment? So they absolutely can be used in the environment, but let me jump first of all into the first part. There's a whole range of pesticides out there. They've been coming to my desk for a good decade. Now, these people I think are interested in actually doing continuous monitoring. So I am showing here what I would sort of call discrete monitoring, but I do want to say that our one of our technologies is called spectrum sensor, and it can pick up things like glycophosphate. The reason I'm being a little bit hesitant is because people say, can you detect pesticides? You know, I'm not sure how many commercial pesticides there are. I would, you know, guess at 20, you know, but, you know, there's an awful lot out there. So it's probably worth saying that we can, so for example here, this is the baseline in just the water, and then these pesticides give us quite a distinct signal. So the quick answer is we can detect pesticides. Again, if you see a link, I'll have put the link underneath the video. We do have this spectrum sensor. The spectrum sensor works with our Sensi All meter. We have apps. The apps tell the meter what to do. The meter gives the data back to the app, and the app gives the data to Julie. Now, this is important because if you're a developer and you want to develop technologies for your clients, then we do have the ability to bring that raw data to the cloud, to process it to concentrations, and then to pass that data on via an API. And so if you have a Julie account, you'll see that there's actually an API link up there, and we have all sorts of, and this list is getting really quite long now, of different API calls that you can make upon Julie. So we describe ourselves as sort of sensor to API business. When we first started this company, we made sensors. Then we found ourselves having to support, which was quite surprising, electronic engineers, as they had to work with the sensors. At that point then, everyone was building their own cloud, so we built our own cloud. So we sort of, at which point now, if you really want to do a fast MVP, fast minimally viable product, then we can provide sensors, electronics, through the apps connect to cloud, and from the cloud then you can call the data across to your cloud using an API and essentially build upon that. One of the parts of the question was, is this stuff intended just for laboratory, or is it in environmental applications? The quick answer is, again, we have a starter kit here where the intention is, and it's more than the intention, this is what's going on, that we have these sensor modules that talk to electronics. The electronics then talk to base stations, and base stations send the data to the cloud. And then you can call upon the cloud using an API. And so these sensors, you know, if we're going to put them into environmental applications is a broad term, by the way, because that can mean so much. You know, it could mean, you know, rivers, seas, lakes, streams, you know. Also, the reason I kind of say that, I mean, just looking at rivers and sea, you know, the one's a salty environment, one's a sort of freshwater environment. So in the end, the way you kind of present or protect the sensor really depends on the application itself. But these sensors will work in the water, and we do try to make them robust so that they can exist in environmental applications. Another part of the question is, can we detect antibiotics? Again, our spectrum sensor is able to, when I look at an antibiotic, you know, it's got what's called heteroatoms, which is nitrogen, oxygen, as examples, and it's also got these aromatic rings. And so our spectrum sensor is able to detect, I call them APIs often, active pharmaceutical ingredients. An example of an API would be an antibiotic, and so the spectrum sensing platform can actually detect that as well. Whoops-a-daisy. They were also asking whether we could detect hormones, and so we do have, you know, cortisol, androstenedione, and testosterone. So we are now there'll be also female hormones as well. We should be able to. We'd have to develop for those, but we can develop those as well, and that can also be run off our Sensi All platforms. I'm just looking at the time. It's 8:19, so I would be a bit quick. Somebody's very interested in either our generation 1 or generation 2 glucose sensing, but they don't really understand the difference. So a generation 1 glucose sensor, the way we make it, we have a sort of electrode, enzymes, and what we call a barrier layer. When the glucose gets through into the enzyme layer, there's a reaction, and the reaction ends up forming hydrogen peroxide. And it's the hydrogen peroxide that we directly detect. That's how glucose sensors started, and then we call that a generation 1 glucose sensor. The generation 2 glucose sensor is pretty similar. And just out of interest, question number 6 is asking about what voltage we use, and there's the answer there. Generation 2 glucose sensors are pretty similar, except we have this catalytic layer in there. This catalytic layer allows us to reduce the voltage that we apply to the sensor, and in reducing the voltage, it helps with specificity. Whether you use a generation 1 or generation 2 glucose sensor, it really depends on the application. So this is an answer I often give, but when you look at CGM, continuous glucose monitoring, Abbott is a generation 2 glucose sensor, whilst Medtronic and Dexcom are generation 1 glucose sensor. So to be commercially successful, it doesn't matter whether you're generation 1 or generation 2. People laud the generation 2 as if it's better, because actually the voltage that you use is lower and therefore the specificity is probably better. But Dexcom and Medtronic, are also doing very well in the CGM space, and they're generation 1 glucose sensors. So difference between generation 1 and generation 2 is generation 2 is slightly more complicated to manufacture. It has a catalytic layer in there, which allows us to lower the voltage and helps with specificity by being less reactive to interferences like ascorbic acid and acetaminophen. Whether you go generation 1 or generation 2, it's quite a conversation actually. It's not a short conversation. I mean, that's really quite an in-depth, almost consulting project to even decide which way to go. But we do have both at Zimmer and Peacock. Question number 5 is they would like to print carbon and silver chloride in a 3-electrode mode on flexible materials. And I think they've thought they're interested in invasive and non-invasive. So it's probably just worth saying that at ZP we do have invasive technologies. Again, if there's a link, it'll be underneath the video and you can follow that. So we do have invasive technologies. I've described this as you can see the forceps here, that's quite invasive. And we also have non-invasive technologies. Again, if you see a link, then that will also link to a website. The first part of the question was, can we actually can we print on flexible materials? This video, there'll be a link to it, shows that we clearly are printing on flexible materials. That particular example does have a carbon ink and silver chloride, so there's no issue in printing on flexible materials and printing in particular the materials carbon and silver chloride. This is also one of our products as well. We have been gently phasing this one out. It's I want to say it's quite old with us actually. This has been around for about 5 years. But it's also a flexible substrate, a flexible PCB. And again, we've got a couple of carbon electrodes on there and a silver chloride. So there's no issue in printing on flexible materials. So I just want to remind myself of the first part of that question as well. Yeah, and we do obviously, we're very experienced with invasive and non-invasive type sensors as well. So the sweat is definitely non-invasive and the implantable sensor was definitely invasive. Question number 6 was really, how do we run these CGM sensors, or these glucose sensors rather. I do have links to these videos underneath, so I just want to say these videos exist. Andre does some nice examples of this. So what voltage and current generation? Can you confirm that the enzyme is ready to use? The enzymes are on our glucose sensors. So I'm getting a question here, which is why does the signal not stay the same for same test solutions? I would say, please give me a more of a presentation rather than sort of an email with some data attached. Please turn it into a presentation, because then I can sort of follow the narrative of what you're doing. The reason I've sort of changed slightly is I do try to answer questions in real time, and I can see that Rohan's asked a question. So I'm asking Rohan to give me more of a sort of presentation mode, the way that I'm presenting now. If you put that into slides, it will really help me understand your questions and what you're seeing more clearly. So question number 6 is around about what voltages should I apply? And it's probably worth saying that we do have a couple of videos on this. I will link to those videos so the questioner can see that. And you'll also see the raw data also coming. In fact, you can see it here coming off these sensors as well. quite modern in some ways. I mean, data sheets are great, but data sheets were kind of essentially existed before there was video. We tend to use video and the website more than data sheets. But I do have some links here to some useful materials about how to use a glucose sensor from Zimmer Peacock and how to test them. Now, by the way, the question also involved, can we use Palm Sense? Yeah, you can use Palm Sense with our stuff, and these videos should be informative. We now don't support Palm Sense with our sensors. The reason being is we kind of it gets very confusing that you've got somebody providing you with a glucose sensor and somebody providing with electronics. They do work together, but when you use them together, you're sort of more on your own, because sometimes people are like, well, is the electronics that's wrong, was the sensor that's wrong? What we've ended up doing is actually making a OEM solution, an original equipment manufacturing solution, where we actually provide single-purpose biosensor boards. This is one example here. There's a drop-down menu, so you can get a sense of what the costs are for different volumes. But what this means is that if somebody wants to make a glucose sensing product, they can actually get one of these boards. Don't worry, once the volumes increase, the pricing drops down a lot. But what we're saying here is that rather than, you kind of get a glucose sensor from a company and then electronics, you either in-house develop or you buy from another company. Actually, if you get both elements from us, then it means that we can support properly, because you don't have one person saying it's the sensor, another person saying it's the electronics. You got them both from the same company. It takes away the confusion about essentially who's responsible. So biosensor electronics, you can find them on the ZP website. Again, I put a link. And the reason we've done this is, to make a sensing system, you often need sensor plus electronics, so that will give you a solution. And so what we've done is we do have sensors, we do have the electronics, and therefore it's easier for us to be able to say, yeah, these things will work together, because we've developed both sides of it. Now, our business model stays the same. That actually we're doing contract manufacturing from others. It's just really these are called OEM solutions that allow other companies to build upon our technologies. So I want to say thanks to Rohan this morning. Rohan, I have shown you how to, I think, calibrate a glucose sensor, but I think with your particular question, I need a more detailed narrative in some slides so that I can really understand the question. How to calibrate a glucose sensor. Question 1 was answering that. Question 6 also has a couple of videos in it, and also the workshops can be quite useful because we do it in the workshops as well. Inflammatory wearable biosensors. That's really just a repositioning of CGM, continuous glucose monitoring technology. The biggest barrier to doing something like that is actually, is that BioLink, was it BioLink? Example when I actually said, look, these guys have raised $196 million US. That's what it sort of takes to do this kind of technology. Can we detect pesticides? Yes, we can do it on our spectrum sensor. Can we detect antibiotics? Yes, we can do it on our spectrum sensor. And hormones, we do have cortisol, testosterone, and androstenone already on the website. Generation 1 and Generation 2 glucose sensors. Generation 2 has this catalytic surface, which allows us to use less voltage, and it should have less interferences. But life is a trade-off, that Generation 2 can be more costly, and Generation 2 is not necessarily an advantage commercially, because Medtronic and Dexcom do have Generation 1 glucose sensors, and they're working perfectly fine. Now, we can print carbon and silver chloride on flex substrates. It's really of no particular issue. And how to use a glucose sensor. We do have a lot of videos out there, and really they are compatible with PalmSense. The enzymes are already immobilized on the sensor. You don't have to add them. And I hope there was a lot of questions, a lot of content. I see it's 8:29 and 53 seconds. We tried to do this in 30 minutes because many of you got meetings. I definitely have meetings now. So thank you very much for your questions, specifically to Rohan. Rohan, give me some more details in a sort of slide set so that I can follow your questions more detailed. Okay, thanks very much, and speak to some of you too. Thanks, Aftab, for all your support. We'll get back to that Indian embassy and try and sort this out. Okay, take care.